It was observed that a volleyball, when spiked horizontal 2.2 meter above the ground at B 9 meter away, determine the initial velocity VA of the ball and the velocity VB and theta of the ball just after it strikes the court at B. Take the coefficient of restitution equal to 0.7. For the first step, to find the initial velocity, we use the equation of motion by using S equal to original of S plus by VAT. So S mean displacement, S O mean original displacement, VA equal to meaning by velocity initial, and T equal to time. So we know that the overall displacement equal to 9 meter. So we put 9 meter equal to original S, which is the initial displacement 0, plus VA we don't know yet, and T we also don't know what is the time for this velocity. So to find V, A, and T, we must find it by each other. So we use the another equation to find it. Do not forget to put sign of the direction. So from this equation, we use it to find horizontal direction. For the second step, we can use equation of motion by S equal to SO plus VOT plus 1 over 2 ACT squared. We put the sign of direction by downward. So the overall distance for the collision or horizontal is 2.2 by using the information that stated in the question. Equal to the initial distance is 0 plus with VOT, which is 0 because the VA is in the vertical condition. Plus with 1 over 2 multiplied by acceleration constant, which is negative 9.81 multiplied by time square. From this equation, we can find time by solving the calculation. We find that the time equal to 0.6697 seconds. After we get the value of time, for the third step, we put the volume of time to the equation that we got from the previous equation, which is this. So from this equation, we put the volume of time that we get from the second step to find initial velocity. So when we solve it, we can find the initial velocity, which is VA equal to 13.44 meter per second. So from the initial velocity that we can get the VB in act condition, which is same with the VA because it perpendicular to the line of impact. From the equation of momentum, we know it that momentum at velocity 1 equal to momentum at velocity 2. So from that we can know the velocity at bx2 equal to velocity at bx1 equal to 13.44 meter per second. So to find the velocity B, which is VB, we use the equation of motion, which is velocity equal to original velocity plus acceleration constant multiplied by time. So to find the VBY, we can use this equation. So to the VB initial equal to 0 plus with the acceleration constant, which is acceleration of gravity, which is 9.81 multiplied with the time, which is 0.6697. When we solve it, we find the velocity VBY1 equal to 6.57 millimeter per second. So from the equation of coefficient of dislocation, we can find VBY2. From the information that given, we put the value of coefficient of dislocation, which is 0.7 equal to VBY2, which is we did not know yet, and over with the VBY1, which is 6.57. When we solve the equation, we can get the VBY2 equal to 4.599 meter per second. So to find the velocity B, we can use the equation of magnitude by square root VBY2 square plus VBY1 square. By using the value that we get before this, we can know it that VBY2 equal to 4.599 and VBY1 equal to 6.57. So when we put the value into the question and we solve it, we can get the VB equal to 8.02 millimeter per second in positive, so it was upward direction. After we get the value of VB, we can find the theta. To find theta, we can use the formula of trigonometry, which is theta equal to inverse tan multiplied by VBY2 over VBY1. From the value that we get before this, we can know that VBY2 and VBY1. So when we put it to the equation of trigonometry that we found, the theta is 34.99 degree. So we have done by finding the initial velocity, which is VA, VB, and theta, by the value that we get, which is VA equal to 13.44 meter per second, VB equal to 8.02 meter per second, and theta equal to 34.99 degree.